Hello everyone, I'm Bin. My report topic is Sinomenine hydrochloride suppresses the stemness of breast cancer stem cells. Breast cancer has become the world's largest cancer in 2020. At the same time, breast cancer is the fifth leading cause of death. In the past few decades, great efforts have been made to develop more effective breast cancer treatment strategies, including surgery, radiation therapy, chemotherapy, hormone therapy, targeted drugs, to improve the survival rate of breast cancer. But approximately 45% of breast cancer patients will have recurrence and metastasis after receiving systemic treatment, and most of them eventually died of metastasis. The main reason may be that breast cancer stem cells will be retained after short-term or long-term treatment with many chemotherapeutic drugs commonly used in clinic. The retained breast cancer stem cells could increase the possibility of tumor recurrence, metastasis, and drug resistance. Breast cancer stem cells, with the capacity of self-renewal and differentiation, have been proven to be involved in all stages of breast cancer, such as occurrence, development, and metastasis. And they are also the key driving factor for the death of breast cancer patients after the distant metastasis. Therefore, targeted breast cancer stem cell therapy as a new emerging method has great potential in the treatment of breast cancers and in control of recurrence and metastasis. In recent years, plant-derived anticarcinogens have attracted much more attention due to their broad safety profile, ability to target heterogeneous cancer cell populations, cancer stem cells, and key signaling pathways. Sinomenine, an alkaloid monomer extracted from Sinomenine acutum, has been reported to have a variety of pharmacological activities, such as anti-inflammatory, anti-angiogenesis, and immunosuppressive. Sinomenine hydrochloride is one of the active forms of sinomenine, which have been developed into 镇清风痛灵 tablets or capsules, and sinomenine hydrochloride enteric-coated tablets for treating rheumatoid arthritis and other autoimmune diseases in China. Meanwhile, many studies have shown that both sinomenine and sinomenine hydrochloride have anti-tumor effect in many kinds of tumors, such as liver cancer, lung cancer, breast cancer, ovarian cancer, prostate cancer, renal cell carcinoma, and glioblastoma. However, the effect of sinomenine hydrochloride on the breast cancer stem cells has not been studied in detail, so we explored the effect of sinomenine hydrochloride on the CD44 positive and CD24 negative breast cancer stem cells. Sinomenine hydrochloride decreased the percentage of CD44 positive and CD24 negative breast cancer stem cells in two breast cancer cell lines. Sinomenine hydrochloride also decreased the expression of CD133, another commonly used breast cancer stem cell marker. In addition, the expression of breast cancer stem cells associated genes, including GUM, MET, MYC, INHBB, CXCR4, HMGA2, and TGF-beta2, were also decreased in the two breast cancer cell lines after the treatment of sinomenine hydrochloride. Furthermore, the ability of the formation of oncosphere, which were used to access the self-renewal of cancer stem cells, was significantly decreased after the treatment of sinomenine hydrochloride for 4 days. This data suggested that sinomenine hydrochloride suppressed the stemness features of breast cancer stem cells. To further investigate the inhibitory effect of sinomenine hydrochloride on the capacity of self-renewal breast cancer stem cells, the CD44 positive and CD24 negative breast cancer stem cells were isolated from MDA-MB231 and MCF7 cells by fence sorting and further characterized by immunofluorescent staining of CT44. After the solid CD44 positive and CD24 negative breast cancer stem cells were treated with sinomenine hydrochloride, the capacity of proliferation, clone formation, migration, and invasion was significantly decreased. Furthermore, the growth of fourth-generation oncospheres was significantly inhibited when treated with sinomenine hydrochloride for 48 hours. Meanwhile, the percentage of Ki-67 positive cells in sinomenine hydrochloride treated oncospheres were also obviously decreased, indicating that the capacity of the proliferation was significantly inhibited by sinomenine hydrochloride. Significantly, the expression of breast cancer stem cells marker, such as CD44 and CD133, and the stemness-associated genes such as GUM, MET, MYC, INHBB, HMGA2, and TGF-beta2 were decreased in sinomenine hydrochloride-treated oncospheres. Overall, sinomenine hydrochloride obviously inhibits the capacity of self-renewal of breast cancer stem cells. Here, we found that some breast cancer stem cells associated genes such as GUM, MET, and MYC are also the target of genes of Wnt signaling pathway, which were reported to play important roles in the maintenance of stemness self-renewal potential and drug resistance of cancer stem cells. So we investigated the expression of Wnt signaling pathway genes in CD44 positive and CD24 negative breast cancers, which were treated with sinomenine hydrochloride. The results of real-time PCR showed that the expression of Wnt10B, RC3, SERPINF1, DKK1, and VAGL1 was significantly downregulated, and the expression of CSNK2A3 were upregulated in MDA-MB231 breast cancer stem cells, while the expression of DKK1, Wnt10B, PLCB, and VANGL1 was significantly downregulated, and the expression of CSNK823 were upregulated in MCF7 breast cancer cells. Together, the expression of Wnt10B, VANGL1, DKK1, and CSNK2S3 have the same trends in both breast cancer stem cells. Among these Wnt signaling pathway targets, Wnt10B, a member of Wnt ligand gene family, has been reported to be involved in the control of stemness, pluripotency, and cell fate dissociation in stem cells. Therefore, we further confirmed that the protein levels of Wnt10B were significantly inhibited in both breast cancer stem cells after the treatment of sinomenine hydrochloride. Meanwhile, the level of beta-catenin was downregulated and the distribution of beta-catenin in nucleus was also decreased in both breast cancer stem cells after the treatment of sinomenine hydrochloride. Furthermore, the expression of downstream target genes of Wnt beta-catenin signaling, including CD44, MMP7, cyclin D1, MET, MYC, and Jun, were downregulated in both breast cancer stem cells after treated with sinomenine hydrochloride. Sinomenine hydrochloride may inhibit the stemness of breast cancer cells by targeting Wnt10B to inhibiting the activity of Wnt signaling. In conclusion, sinomenine hydrochloride inhibits the stemness of breast cancer cell by targeting Wnt10B to inhibit the activity of Wnt signaling. Thanks for your listening.